Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video we're going to cover the fundamentals of sockets. Now on this channel we have a lot of different videos that are networking related, for example TCP chats or Zoom clones or streaming audio data, streaming camera data and so on. But we don't have a video that covers sockets in detail on a fundamental level. So what is a socket? How does it work? How do we create it in Python? What are the different parameters that we pass? So what does, for example, AF-INET mean? What does SockStream mean, and so on? So what are the different protocols that we can use? And in this video, we're going to talk about sockets on a fundamental level, and we're going to build a basic server client system, client-server system in Python. So let us get right into it. Alright guys, so we're not going to start with the coding right away, we're going to start with some theory, and this is because I want to make sure that you understand some basic concepts first. So for example, what is a client, what is a server, what is a client-server architecture, what are IP addresses, what is the difference between a local IP address and a public IP address, what is a socket, what are the different protocols that we can use, what is the difference between TCP, UDP, and so on. So we're going to talk about that here first, and then we're going to get into coding. And for this, I have on my second screen here a couple of notes. I don't want to rely on them, but maybe I'm going to look at them a couple of times to make sure that I don't miss anything so that you get a full explanation. So don't be confused by that. We're going to start with something very simple, which is the client and server architecture. I'm just going to write down client server here. What is a client? What is a server? And the client server architecture then is just basically the way that we structure a program with clients and servers. So a very basic idea of a client and server is we have, I don't know, some central server here. Some central server here, which we're just going to call server. And then we have multiple clients connecting to that server. So let's say we have a PC1 here. We have a PC2 here. We can also have a phone, for example. It doesn't have to be a computer. We can have, I don't know, a PS4 and some smart devices, some smart refrigerator, for example, or anything that can communicate with the server. And then we have these connections. So PC1, for example, can make a request to the server to talk to PC2. And then PC2 gets a message. So for example, I can say hi, and it says hi to PC2. I can do that like that. The important thing is that I'm not connecting. So PC1 is not sending the message to PC2, but PC1 is sending the message to the server, and the server is then sending it to PC2. Or we can also just broadcast it to PC2, to the phone, to the PS4. By the way, I missed the phone here. There you go. So this is something that we can do with the server. And of course, this server can have different purposes. It can be a chatting server, so we can just say this is a server for a message exchange. So this can be a chat room, and everyone can send messages that are broadcasted to everyone else. Or it can be a gaming server for some, I don't know, some online game that is cross-platform, so I can play it on PC with someone that is playing it on a PS4 with someone else that is playing it on a phone. And this server is managing all the actions. So for example, if this person in the game walks somewhere, everyone else needs to know as well. And then this person walks somewhere and everyone needs to know as well. So just a basic central piece, a basic central entity that processes requests with gives us responses. So for example, I'm sending something, I'm receiving something. This is also what server stands for. We have the client is requesting something, and the server is responding. It's serving the client and giving the client an answer. So this is a very basic explanation of what a PC and a server is. Now let's get a little bit more detailed, because in reality or in computers, we always have some addresses. We're not going to get too deep into the different models, because there is a standardized OC model with layers. So we have basically layer 1, layer 2. Layer 2 is like MAC address, and layer 3 is then IP address. So we're not going to talk about that in too much detail here. But what you need to know is that essentially communication happens, or the addressing, not the communication itself, the addressing happens with so-called IP addresses. I'm sure you have heard of that. And let's say this here is a local area network, so a LAN. This is a local area network. This is not the internet. This is all in one home with one router and so on. And each of those devices have a certain IP address. So for example, this could be 192.168.0.15, for example. This is the IP address. The PC could be 192.168.0.8, for example, and so on. Those have similar IP addresses. And whenever I want to do something, for example, I'm hosting the server on this IP address and this computer is connecting to that IP address, those are the relevant IP addresses. So the server is hosting the server on its own IP address here. And if the computer wants to connect to that server, it has to connect given that IP address. And of course, we're going to see later on, we also have ports. So we're not only connecting to 192.168.0.15. No, we're also specifying a port number. For example, I don't know, 9090. You can think of a port number as a door to a room. So let's say, maybe not the best analogy here, but let's say we have a house and the house has certain rooms. So we have a room here, we have a room here, and a room here, and a room here. So this room, for example, could have the IP address 192.168.0.15, but it has different entrances. So this is entrance A, this is entrance B, this is entrance C. So different doors that I can use to enter this room. And those different doors can be controlled by, I don't know, security or something. But basically the door I use is the port I use. So I get to the same room, I get to the same location, to the same IP address, but I'm using different ports. So this is important. If I want to enter with port 9090, for example, the server also has to listen at port 9090 for incoming connections. Otherwise, it's not going to open the door for me. So this is some very basic stuff. Now we're going to expand on that because this is in a local area network. What we're talking about here is a so-called local IP address. This is a private IP address. You can get this IP address, and we're going to look at that in a second, on Windows by typing ipconfig into the command line, or on Linux and Mac if you type ifconfig. You're going to get that IP address. This is a local IP address that you have in your home. So in your home, you have your IP address, and this is only private. If I show you my local IP address, so let's say this was my local IP address, you're not going to be able to connect to me via the internet, even if I'm hosting something and even if my firewall is open and everything is fine, you're not going to be able to connect to me because of the fact that this is my local IP address. You can only address me with this local IP address if you are in the same local area network. So you're not able to address me with that IP address if you're somewhere out there. For this, we have a so-called public IP address. So let's say this here is my local area network. So this is my home network, LAN, and somewhere here I have a router. Let's just say this is a router, and it's connecting me to the internet. Okay, in the internet, I have a different IP address. I don't have those local IP addresses because the good thing about local IP addresses is there are three types, three classes. We have 192.168, we have 10.0, and so on. We have different types, but the good thing is chances are that if you type ipconfig or ifconfig, you're going to have an IP address with that pattern. So you're going to have 192.168 and then some numbers. So everyone has, or multiple people have, those IP addresses. They're not unique. In the internet, if you address me on my IP address, it's going to be unique. So for example, let's say in the internet, I could have, after a so-called network address translation, after a so-called port address translation, sometimes also called PAT. We're not going to get to the details here. I have a different IP address. So all my local IP addresses are, in the case of port address translation, translated to one public IP address. So let's say imaginary IP address, this could be something like 76.28.44.211. It's not going to be my IP address, so this is the IP address of someone else. Don't think that this is in any way a relevant IP address, but this could be my public IP address. So if I give you that IP address, this is what you have to address me with if you want to connect to me. So let's say you're also in the internet, you have another router here, and you have your local area network with your devices, computers, phones, servers, whatever. if you want to make a request to my server that I'm hosting on this local IP address, you need to address me using that IP address here. So this is my public IP address, for example. This is my local IP address. Now, the important thing is, and this is what we always need to keep in mind when we're creating network applications in Python, for example, the server has to be hosted on this private IP address. So when I say server.bind, which is the function we're going to use later on for binding the server to a certain host and port, I need to specify my local IP address. However, if you are not part of that local area network here, if you're part of some other network in the internet and you want to connect to my server, even though it's hosted on that private IP address, you need to connect to the public IP address. This is important. So this is the basic thing that you need to know when you're communicating using sockets and using networking protocols via the internet. All right, so you should now have a pretty good understanding of what an IP address is, which one to specify when connecting, which one to specify when hosting, and you should also understand what a client-server architecture is. So let us now talk about sockets, because this video is about sockets. Let's not forget that. And what sockets are is just communication endpoints. So if we have a point A that wants to communicate with a point B, through whatever way, a socket is basically just a communication endpoint. So this is a socket and it's communicating with the other socket. It doesn't have to be an internet socket. So we can have a communication that is not based on the internet. So for example, we have sockets for an operating system or on an operating system level. We have sockets that are Bluetooth sockets. So for example, for those of you who have used sockets in Python, we're going to talk about that in a second as well. But when we specify a socket, we always specify like socket.af_inet, which basically says this is an internet socket. But AF inet is not the only thing that we have. We also have, for example, AF Bluetooth, right? This is a Bluetooth socket. So a socket does not have to be an IP socket or an internet socket. It can also be a Bluetooth socket, an infrared socket. It can be an operating system level socket. So it's just a communication endpoint. It doesn't necessarily have to do anything with networking. Having said that, in this video, we're going to mainly focus on internet sockets. So we're going to mention the different, or we already mentioned the different sockets like Bluetooth, infrared, and so on. But we're mainly going to focus on the internet sockets which are specified with AF inet. And here we have AF inet for IPv4, which is IP version 4, and we have AF inet 6 for IP version 6. But again, we're going to mainly focus on IP version 4. So this is what we use the sockets for. In this particular tutorial, we're going to talk about those. But in the context of an internet socket, we still have different sockets. So when we specify sockets in Python, we first specify AF inet, for example, but then we also need to choose, is this socket of type sock_stream, or is it of the type sock_dgram, which stands for datagram. And the difference here is, in the context of an internet socket, sockstream is TCP and sockdgram is UDP. Those are two different protocols. Now, let's see if I remember what TCP stands for. I think it's a transmission control protocol. I hope this is right. I hope I don't protocol. I hope I don't talk any bullshit here. And UDP is a user datagram protocol. Now, if I made a mistake here, you're going to see it somewhere here. But I think this is a transmission control protocol, and this is a user datagram protocol. And those two protocols are what we're basically using when we're communicating. So if I have a chat, I can use TCP to transmit the messages, or I can use UDP to transmit messages. Which one we're using depends on what we're trying to do here. But those are the two different things that we can specify. We specify a socket in Python, for example. It's the same in C, by the way, as well. When we specify a socket, we can choose, okay, is this an internet socket? Is this a Bluetooth socket? Is this an infrared socket? And then when we have chosen that, we can still choose, is this a stream socket or a datagram socket? Not only for the internet sockets, in the context of internet sockets, we have TCP and UDP, but also if we choose something else, we can choose stream or datagram, and then it's going to choose the necessary protocol. So we don't need to specify the protocol per se. It's going to choose the right protocol. We just have to specify, do we want sock stream or sock dgram? Those are just types, and the combination results in a protocol. The important thing is that you want to choose sock stream whenever you are interested in, and we use a different color. You want to choose sock stream whenever you're interested in a connection-based socket. A connection-based socket basically means you have this point A and you have this point B, and you want to establish a connection, and you want to exchange messages, and once the connection is done, or once the exchange of messages is no longer needed, we terminate that connection. That is a connection-based socket. And then on the other hand, we have sock dgram, which is a datagram based socket, where we basically say, okay, I send a message to B and that's it, and B sends a message to A and that's it. So we have those individual messages as datagrams instead of a connection within exchange that we can terminate. This is basically the difference here. So some differences in general between TCP and UDP. Let me just get rid of all of that here. Come on. Some differences that we have here. For example, TCP is what you want to choose if you want to have a reliable connection, because TCP is, as we already said, connection-based. It's reliable because you can detect packet loss. So if you send something in TCP, you're going to get the response that it was received. So you have the confirmation that the packet was actually sent and it arrived. Whereas UDP, you just send it, and if it is lost, it's lost. That's it. So we can detect packet loss here. It's reliable. It's connection-based. It's sequential. So basically in TCP, you send one message, another message, another message, another message, and another message, and that is the order that the other communication endpoint is going to receive the message or the packets in. So 1, 2, 3, 4, 5. In UDP, that's not the case. In UDP, you send the packets and maybe they're going to arrive in a different order. You're just sending them. Maybe they get lost. Maybe they arrive in a different order. So you don't have this sequentiality here. It's also a byte stream. This is important. TCP is a byte stream. And we have, it keeps up a connection. It keeps up a connection and has a message exchange in that connection, and it terminates when we don't want this exchange anymore. So this is TCP. On the other hand, well, let's actually not delete that. Let's just add it to the right here. On the other hand, we have UDP. And UDP is not reliable. It's datagram based, so it sends exactly one datagram, and that's it. And if you want to answer, you got to send a datagram as well. And if you want to send a second message, you send a second datagram, but they're not related. They're not sequential. So I can send 1, 2, 3, and the other one is going to receive 2, 3, 1, for example, because they're not connected. They're not linked. They're not sequential. There's no order, no guarantee whatsoever. So let's write that down. No order, no guarantee. And no noticing of lost packets and so on. So you might be asking, why the hell should I use UDP if TCP is so much more reliable and sequential and it has a connection, all that? The thing that is good about UDP is it is more real time. Doesn't mean that TCP cannot be real time, but UDP is faster. You can just say it's faster and it has less network and PC stress, because we don't need all these controls. We don't have a connection. We don't have all these detections. We don't have all this reliability, and this reliability, of course, comes at a cost. UDP is just faster, real time, and if some packets are lost, who cares? So the question is, when should you use UDP and when should you use TCP? TCP in general, you want to use it when you cannot allow for packet loss. If you want to have what you have at point A, you want to have at point B, and if it is not there, you want to know that, so you want to resend packages and so on. For example, if I'm transmitting some text or if I'm transmitting an image to you, it doesn't matter if it arrives 1 or 2 seconds later, but I want the full thing to arrive at your point. So I'm going to use TCP. Whereas if we have a real-time video connection or audio connection, if I'm streaming some audio, streaming some video, or if we're playing some games, and not every single bit of data is important, because just because we can lose packages, it doesn't mean that we will lose all the packages all the time in UDP. It just means that some packages can be lost and they're not going to be resent unless we implement something on top of that. But if we can handle packet loss and we want to have the best real-time experience possible, we might want to go with UDP. Otherwise, we're going to go with TCP probably. All right, so as a final example before we get into the coding, I want to mention, for example, that Skype, which is used mainly for video communication and audio communication, is using UDP when it comes to the actual call. So if we have a person A and a person B and they're talking to each other, so this is the actual call, as far as I know with the research that I have done, this call is running via UDP because it's more real time and because we can handle packet loss. However, the actual call request, so basically A calling B and B answering the call, this whole exchange here is happening via TCP. So A is calling B and B says, okay, yes, I want to get on a call with A. So this is happening via TCP. Also, the whole message exchange and the images and the emojis, everything is happening via TCP, but the actual call is happening via UDP, as far as I know. So no guarantee that this is 100% correct, but this is, first of all, how I think Skype does it, how I read that Skype does it. But even if it is not exactly how Skype does it, this is definitely a scenario that makes sense. Besides that, for those of you who are interested, Vidstream, the library that I have written, is in the alpha version, so it's not a good library yet, but we have used it in a couple of videos. For example, the Zoom clone. Vidstream is running on TCP. I'm not saying that this is necessarily good, but Vidstream is running on TCP. All the video streaming, the audio streaming is running on TCP. Maybe I'm going to change that in the future because it works, but maybe it's more efficient if we use UDP. So maybe I'm going to rewrite the whole module and make it a little bit more efficient with UDP over time. But this is just a fact that I wanted you to know. You can also stream video with TCP. It's not impossible. All right, so let us go ahead and implement all that knowledge into Python now. And for this, we're going to start by creating a new file, which we're going to call server.py. And in this server, the first thing we're going to do is we're going to import the socket module. So we're going to say import socket, because this is what we need in order to work with sockets. And this server is going to be the server, obviously, of the client-server architecture. And we're then going to also have a client.py, which is going to be able to connect to the server. And the server is going to be running all the time. The clients are going to connect to the server. And whatever we want to do with that server can be done without a problem. So we're going to start by saying socket equals socket. And you need to get used to that. Whenever you work with sockets, you're going to use the word socket quite often. So we're going to say socket equals, or maybe socket is not the right term here. Let's say server equals socket dot socket and then socket dot, and here we need to specify what kind of socket we have. So we say server equals socket socket, and then socket dot, and we need to specify AF underscore. And as you can see, we have a bunch of different socket types here. We have very different types. For example, here, as I already said, Bluetooth. What we're interested in is iNet. So AF underscore iNet. And then we specify socket dot sock, and then we have sock stream or sock dgram. We're going to use sock stream in this video. So we're going to build a TCP socket here. We're going to use a TCP socket here. And this is now a socket, but we don't know what this socket is going to be used for. It's nowhere defined that this socket is going to connect to something or that it's going to be hosting something. So we don't know yet that this is going to be a server. In order to make clear that this is a server, we need to bind it to a host and a port. And we're going to define host and port up here as constants. So we're going to say host equals, and as we already talked about, we need to specify the private local IP address here, no matter if we're awaiting some internet connection or if we if we do this in a local area network. We always need to specify a private IP address. Now, if you don't know your IP address, you just open up the command line, so cmd. You can do that by just clicking on start and saying cmd, and then command prompt. And in here, you type ipconfig. And don't be confused by all the different adapters. For example, one thing that you need to keep in mind is if you have VirtualBox installed for virtualization purposes, you're going to have an own adapter for VirtualBox hosting. And then you're going to have an IP4 address here that is not the address that we're actually interested in. We want to know what is the Ethernet adapter address if you're using Ethernet, or alternatively, you have wireless LAN, which is basically just your Wi-Fi, and then you want to go to IPv4 address, and this is the address that you're interested in. So 192.168.0.206 in my case, maybe something else in your case. It doesn't have to start with those two. This is one possibility how a private IP address can start with. The other is I think we have 10.00 whatever, and then we have something with 172, and I don't want to continue because I don't know what the rest is, but we have these three classes basically. And once you know your IP address, you can just manually type it in, 192.168.0.206. Or what you can do in Python, but it doesn't work if you have a VirtualBox adapter, at least not in that way. Because it's going to take this IP address if you do it. But what you can do in Python is you can say host equals socket.getHostByName, socket.getHostName. And by doing that, you automatically get your private IP address dynamically. So if you run this on a different computer, you're going to get the private address of the different computer, of the other computer. However, as I said, if you're using VirtualBox, it's not going to give you that IP address. It's going to give you the VirtualBox IP address, which is a problem. So I do it manually here. And then what we need to do is we need to specify a port. When choosing the port number, it's important that you don't choose a well-known port or a reserved port. So you don't want to choose 80, for example, which is for HTTP. You don't want to choose 22, which is for SSH. You don't want to take any of those lower numbers that are reserved for common uses, but you want to take something like 9090, for example. I'm sure someone is using 9090 as well, but you just pick something that is not too well known. And if 9090 does not work, you take 9999, for example, whatever. It's important that you have the same port in the client and in the server. By the way, if you're just interested in hosting this on this computer only, you can also specify a local host here, or also 127.0.0.1, which is also localhost. But if we're doing this in a local area network or in the internet with different computers, you want to specify your IP address here, your private IP address. So then we just have to say server.bind. And we don't pass host and port, we pass a tuple of host and port. So inside of those parentheses, again, we have parentheses, host and port. So server bind host port. And then what we do is we start to listen for incoming connections. So we say server.listen, and we can optionally, we don't have to, if we want to limit the possible connections that are waiting for accepting, or for acceptance, we can limit it by passing a 5, for example. So this basically means how many unaccepted connections do we allow before we reject new ones. So when we connect to that server, we can accept it or not, but until it's accepted, it's waiting basically. And if more than 5 connections are waiting, we just reject new connections. We don't have to do this, but this is one thing that you can do. So server.listen, and then what we can do is we can just say while true, basically an endless loop. And now we can accept connections. This is unconditional. We just accept all the time every connection that we have. And the return value of the accept method, so we say server.accept, is 2 values. So we have, first of all, another socket that we can use for the connection. So I'm going to call this communication socket, and the address of the incoming connection. This is what we get from the accept method. So basically what this method is doing, if no connection is coming in, we're just waiting here. We're doing nothing. We're waiting for connections to come in. Now, when a client tries to connect to that server, this accept method triggers, and it returns the address of the client that is connecting and a socket that we can use to talk to that client. It's important that you don't think that we can use the server socket to talk to the client. We use this socket here to talk to the individual client. So the idea is that for each connection, we get a new socket that allows us to communicate with this client, because this socket here is just for accepting connections. It's not for the communication. The communication socket is this socket that is returned from the accept method. This is very important. So when we get a connection, we can just say print connected, or connected to address, so that we see the IP address. And then we can say message equals, and we get the message from the client. Of course, if we receive a connection or expect to receive, not a connection, a message, if we expect to receive a message from the client, we're waiting for that message. Now the client, since we have the same scenario here, the same use case, the client should also send a message. If the client doesn't send a message, we're just going to wait and not receive anything. So it's not going to work. Whenever we try to receive, the client has to try to send. And whenever we try to send, the client has to receive. So we say message equals communication socket dot receive, like that, RECV. And here we specify the buffer size. So how many bytes? Usually we take something like 1024 bytes. So we receive that, and then what we do is we decode it, because when we send messages via sockets, we need to encode them so that there are byte streams, because we don't want to send just strings. We have to send byte streams. So we encode them with a certain encoding, and we decode them. You can just use ASCII, for example, or you can use UTF-8, whatever you want to use. So we decode that, and we can print f-string message from client is, and then just a message. There you go. And then we can send a message back to the client if we want to. So communication socket dot send, for example, and we're going to send got your message, thank you. Now, as you can see, this is now not valid, or it's underlined, because we have to encode it, because we cannot send strings, we need to send bytes. So we say encode UTF-8. And once this is done, we can close the connection. So we can say communication socket.close. We're done with you. You don't have to close it. You can also keep it up and send more messages if you want to. And then we can say print connection with address ended, for example. So this is basically the server. Now, this server is, of course, not perfect, because we cannot handle multiple connections at once. This is where we would introduce multi-threading. We're not going to cover multi-threading in this video, because I have a lot of videos on chat servers, on Zoom clones. Just go to my channel and type TCP chat or Zoom clone or camera streaming or camera chat, whatever. You're going to see how this is done, especially in the TCP chat. I do it manually without using VidStream, so you can just go to TCP chat and you can see how you can handle multiple connections. This video is about sockets, so we're not going to get into threading too much, but this is a basic server. So here we can receive a message, we accept connections, we receive messages, we print them out, we send a message back, and we close the connection. A very basic server. So now we need a client that is going to send something to that server. So client.py is going to be the second file. And the client is going to be quite simple. We again import socket. And as a host this time, we specify the IP of the server. We're not interested in our own IP. We're interested in the IP of the server. Now, since I'm running this on the same computer, obviously it's going to be the same. So in this case, 192.168.0.206. If you're not running this on your own computer, you need to, or on the same computer, the client needs to specify the host of the server. So let's say I have a second laptop here, and this client is running on the second laptop. The host I specify here needs to be that host, no matter what the IP of this computer is. However, as we already talked about, if this is not in the same local area network, if this is in the internet, so not in the LAN, but in the internet, if this is the case, we specify this host here, but here we need to specify the public IP address. So where do you get the public IP address? Through services like, for example, myip.is. You just visit that website, and you know the IP address, and you can ask the guy, okay, what's your public IP address? Let me know that. This guy says, for example, I don't know, it's 87.234.99.12, for example, and then you connect to that host. Of course, the firewall needs to be open and all that stuff. But this is important. You specify the private host for hosting, and you specify the public IP address. In this case, it's the same because we're running this on the same computer. There you go. And the port has to be the same as well. So 9090 in this case. Then we create a socket again. It has to be, again, a socket.socket with socket.internet, AFINet. And it is also a TCP socket. There you go. But this time, since we're not hosting, but since we're connecting, we don't call the bind function, we call the connect function. So we say socket.connect, and we pass a tuple again. So inside of the parentheses, we put parentheses, and we specify the host and the port. That's how it's done. And now we're connected to the server if the server accepts us. So this sends a request to the server has to accept it. And once it's accepted, we go past that statement to the next statement. And this is going to be just socket.send hello world, for example. We encode that, of course, UTF-8. And then we just print whatever we receive from the server. So socket.receive 1024 bytes, and that's it. So as you can see here, we have only one socket we connect and we send with the same socket. Here we have a socket for hosting and then an individual socket that we use for the connection with the individual client. So this socket here is just for running the server, listening for new connections, and maybe accepting them, as you can see here. And once we accept them, so once we have a connection here, this is one endpoint for the client, and this here, not this here, this here is the other endpoint for the server for the communication. So let's see if this works. We're going to open up CMD. We're going to navigate to desktop, to programming, to Python, to Neural 9. And we're going to run the server here. We're going to say python server.py. Server is running, nothing is happening, obviously. And then we're going to open up command line again, cd desktop, cd programming, cd python, cd neural 9. And then we're going to run a client. And as you can see, let's just split this here. You can see connected to, this is the IP address. Message from client is hello world. And here, got your message. Thank you. Oh, we didn't decode that, which is why we see this byte here. It's not really a problem, but if we want to get rid of that, we just say .decode UTF-8. And then this is also no longer a problem. So let's rerun this. We can do this again, or maybe it's closed already. So let's run this again. CMD, desktop, programming, Python, Neural 9, Python, client.py. There you go. We got a problem here. String has no attribute decode. Why is that? Of course it has. Where is that? 18 in server.py. Oh yeah, doesn't have that because I entered this at the wrong position, I think. Here we need that .decode UTF-8 because here we print what we receive. Okay, now it should work. So now if I run the server again, and if I run the client again, there you go, you have no byte here, and we have all the messages here. Alright, so that's it for today's video. Hope you enjoyed it. I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video, and bye.